Hello, my name is Truman Tapia, and I am going to present about my project for the subject Tipología y ciclo de vida de los datos of the Master in Data Science of the University UOC in Spain. This dataset is based on the data Top 200 Common Password by Country 2021 from this page. So this project uses R programming language, and the analysis uses a statistical test to get some knowledge from the dataset. My name is Truman Tapia, and I am the author of this project. Here you are in the GitHub repository of the project. But let's move on to the project itself quickly. So this is the report of the project, which you can find in the GitHub repository. And let's start by loading the data. We have 9,800 rows and 8 columns. This is a description of the columns. We have the first two columns show us the information about the country. Also, we have information about the ranking by country and a global ranking of each password. The column password shows us the actual password. User count tell us how many users are using the password. And time to crack in seconds tell us how much time do you need to crack a specific password. So once we know what the dataset contains, we move to data pre-processing phase. First, we get rid of country code and time to crack because they are redundant with other columns. So we get rid of these columns. Then we study and we make sure that we don't have weird data such as zero values where they are not supposed to be, missing values, outliers, and also duplicated data. And we do this so that we can get a data in good shape to make a subsequent analysis. Also, we start by exploring each column so that we make sure that everything is consistent. And here you can see the countries in the dataset and the number of times that they appear in the dataset. In this case, each country appears 200 times, because the dataset collects the top 200. Also, to take a look on the type of password that appears in the dataset, here you can see a word cloud with the most common password. And you can see that the most common passwords are silly combinations of numbers and words and letters. And from the word cloud, and for this bar plot, where you can see the frequency, the number of users using a specific password, you can see that there is a peak of people using the silly passwords. Also, we can take a look on the histograms of the numeric variables. Here you can take a look on them, and also the box plot of these numeric variables, so that we can analyze the possible presence of outliers. But once we have end the pre-processing, we move to the analysis, and we are going to answer 4 questions. First, what is the countries where it is easiest to crack passwords? Is there a statistical difference between the easiest country and the second easiest? So to answer this question, we are going to use the mean time to crack in seconds, and the country by country. And the country with the lowest mean time will be the easiest country to crack a password. And we are going to compare the sample data of the two easiest countries to make sure that the distributions are different, and in fact one country is easier to crack a password than the other. So here we start by calculating the mean time to crack a password by country, and here they are ordered. So you can you can look that the United States and Korea are the top two easiest countries. So we are going to compare the sample data of these two countries to check that they are different. So first, we are going to expand the data because the initial data set contains frequency data. So we are going to expand the frequency data to sample data. And once we get the sample data, we have to decide whether to use a parametric or a non-parametric test on this data. So we're going to test normality and elasticity. Taking a look on the histograms of the data here, we know that normality may not be fulfilled, but we check this with a Kolmogorov-Smirnov test and give it that the p-value is really small, the null hypothesis is rejected, and the data may not follow a normal distribution. And now let's check for homosedasticity with a Flickner-Killen test, and we also find that this homogeneity of variances is rejected. So now that we have done this, we are sure that we have to use a non-parametric test. So we use a Wilkinson test to compare the sample data of United States and Korea, and the test rejects the null hypothesis. So the distribution of this data for the two countries is different. So United States is the easiest country to crack a password. Now we can make a similar question: what is the country where it is the hardest to crack a password? And to answer this question, I follow the same approach as the last question. And let me quickly move to the answer. And in this case, we have that the top hardest countries are Indonesia and Chile. But after comparing the two samples, Indonesia is the hardest. Now, the third question is there any statistically difference in the time to crack a password among the countries in Latin America? So here we are going to see if the countries of Latin America follow a similar distribution in the time to crack a password, so that we can see if they have similar patterns in the password. So we follow a similar approach. We expand the data based on the frequencies, and taking a look on the histograms of the data of each of the four countries which are in Latin America for this data set, we know that we have to make a non-parametric test. So we use a Kruskal-Wallis test, and we find that at least one of the countries does not follow the same distribution as the rest. So it's not the same to crack a password in all the countries of Latin America. So finally, we are going to study the correlation between the numerical variables of the data set. And here you can see the correlation matrix and the p-value matrix for the numeric variables of the data set. And taking a look on the values, we see that any pair of the variables are not highly correlated, and also the p-value is approximately zero, which tell us that the correlation values are significantly statistically significant. So to take a look on the relation and the correlation of the variables, we see here a scatter plot of the variables, numeric variables, and we see that we don't have correlation in these scatter plots. So basically, this is the project that I've done. Thank you for watching.